विद्यार्थी मित्रांनो, तुमचं या लेक्चरमध्ये स्वागत. आपण सेमीकंडक्टर डिव्हाइस हा टॉपिक मध्ये गेल्या वेळी डायोडच्या वेगवेगळ्या प्रकारची माहिती घेतली आहे. त्याच्यामध्ये आपण झिनर डायोड पाहिला, त्याच्यानंतर फोटो डायोड पाहिला, त्याच्यानंतर सोलर सेल पाहिला, त्याच्यानंतर एलईडी, प्रत्येकाचे ऍडव्हान्टेजेस. आजच्या लेक्चरला आपण पुढचं सेमीकंडक्टर डिव्हाइस पाहणार आहोत, ट्रान्झिस्टर, ज्याला बायपोलार जंक्शन ट्रान्झिस्टर किंवा शॉर्ट फॉर्म मध्ये बीजेटी असं म्हणतात. त्याला बायपोलार का म्हणतात? तर ट्रान्झिस्टर मध्ये जो करंट वाहतो, आपले जे ऑर्डिनरी मटेरियल्स आहेत किंवा मेटल्स आहेत, त्याच्यामध्ये जो करंट वाहतो तो फक्त इलेक्ट्रॉन मधून वाहतो. परंतु ट्रान्झिस्टर मध्ये करंट कॅरियर हे इलेक्ट्रॉन्स आणि होल्स दोन्ही असतात. सो करंट कॅरिड बाय बोथ polarities, that is current as well as hole, hence called as a bipolar. This transistor has a two junctions and three terminals, and there are three doped regions called as emitter, base, collector, and pin are connected to each region. So there are also three terminals, that is emitter, base, and collector. They forms two junction because base is sandwiched between emitter and collector. So there are two junction, EB, that is emitter base junction, and CB, that is collector base junction. So emitter, if we compare these three regions, that is emitter, base, and collector, it is found that emitter is thick, base is thin, and collector is also thick. But emitter is heavily doped. Emitter is heavily doped. Base is lightly doped, while collector is moderately doped. Emitter is moderate in size, base small in size, and collector, its area is larger than emitter and base. So these are the three regions of a bipolar. So there are two types of transistor, that is NPN transistor and PNP transistor. NPN means P-type semiconductor is sandwiched between two N-type semiconductors, then A forms NPN transistor. Similarly, if N-type semiconductor is sandwiched between two P-type semiconductors, then that transistor is called as PNP transistors. So these are the two types. So the symbol of NPN and PNP transistors are as shown in figure. The difference is that there is an arrow to the emitter terminal. So emitter terminal shows an arrow towards the base, base, and it actually shows the direction, conventional direction of emitter current. So in a PNP transistor, this arrow is towards the base, while in NPN, this arrow is away from the base. So direction of arrow represents the direction of conventional current. So there are three types of current. First, that is emitter current IE, base current IB, and collector current. We see that there are two junctions. So emitter base junction has low resistance, while collector base or base collector junction has a high resistance. So the transistor configuration. There are three types of configuration of transistors, that is common emitter configuration, common base configuration, and common collector configuration. In common emitter configuration, emitter is common in input as well as output. Similarly, in common base configuration, base is common to both input and output, while collector is common in common collector configuration to input and output. Because transistor has a 3 terminals, we require 2 for input and 2 for output. So we require 4 terminals, so that we have to make a one region common input as well as output. So these are the 3 configurations: common emitter, common base, and common collector. Now see the common emitter configuration. So this is the circuit diagram. So here emitter is common in both input as well as output. Input signal is base and emitter, and output is measured across the collector and emitter, so that emitter is common. Produces a highest current gain as well as power gain. Because input impedance is low here and output impedance is high, because the resistance of emitter base junction is low and the resistance of emitter collector junction is large. So we have, according to Kirchhoff's law, emitter current IE, that is equal to base current IB plus collector current IC. So here current gain or current amplification factor is given by equation beta DC, which is equal to output current divided by input current. So there are two, collector current is a output current. Here are 2 input current, that is base current and emitter current. So the ratio of collector current to base current is called as the ratio beta. Beta DC is equal to IC upon IB. And similarly, alpha DC, that is equal to IC upon IE, that is the ratio of collector current to emitter current. It is found that the emitter current is equal to IB plus IC, that is IE is larger than IC. Therefore, alpha is always less than 1, while beta has a larger value ranging from 20 to above. From above equation, we have IC. From above equation, we have IC, that is equal to alpha IE or beta IB. Therefore, alpha DC is equal to beta upon 1 plus beta, or beta DC is equal to alpha upon 1 minus alpha. Small change in base current controls the current in emitter collector circuit. This property of transistor enable us to use a transistor as an amplifier. So here in your textbook, the range of beta DC is equal to 20 to 200. So let us see the working of NPN transistor. So you see the circuit diagram as shown in figure. So in NPN transistor, the electrons are majority carrier. So when input junction is forward bias is applied, electron in emitter region have not entered in the base region. When biasing voltage is greater than barrier potential, many electron enters in the base region from the emitter, forms the emitter current IE. Electron flows in a 2 direction, forms base current IB and collector. So collector current is 95% of emitter current, because the electrons which are enter in the base region are attracted by a collector region for the collector current, while some are passed through the base forms the base current. So the working of PNP is also same, but here majority current carriers are holes. So we have relation emitter current is equal to base current plus collector current. So see the some characteristics of transistor, that is a common emitter characteristics. This characteristic is shown as in figure. The variation of base current with a base emitter voltage when collector emitter voltage kept fixed. That curve is called as an input characteristic. Initially, current is small. After barrier potential, its characteristic is similar to forward bias PN junction diode. So here, input dynamic resistance is Ri. Input dynamic resistance Ri, that is equal to delta VBE divided by delta IE, that is input voltage divided by input current when VCE is constant. Now see the output characteristics. Variation in collector current with collector emitter voltage when base current is constant is called as an output characteristic. It is shown in the below figure. That is the variation in collector current with collector emitter voltage when base current is constant. So when base current is increased, it is found that the saturation value of collector current goes on increasing. When the base current is 0, there will be no increase in the collector current. So there forms the three regions. That is first, that is cutoff region. Then this is active region. This is cutoff region, active region, and saturation region. So collector current is independent of collector emitter voltage. Collector current has a large value than that of a base current. So here output dynamic resistance is given by output voltage divided by output current, that is RO is equal to delta VCE divided by delta. So this is about the input resistance and output resistance. So we see that the very small change in base current causes a very large change in collector current, and this collector current is sent through the high resistance called low resistance. In this way, we get the same variation as in the base current in a large scale. This property of transistor enable us to use a transistor as an amplifier. The required circuit as shown in figure. In this figure, we see the transistor as an amplifier connected in a common emitter configuration, which gives the large voltage gain as well as large current gain and power gain. So amplifier device used for increasing the amplitude of AC. NPN transistor and CE configuration is used. When input signal is not applied, the negative sign output and input voltage is there because here output is out of phase that of input. That is, there is a phase change of 180 degree or pi radians. So see how the transistor works as an amplifier. So connect the circuit as shown in figure. So here emitter is a common, RB is a base resistance, RL is a output resistance, VCE is a collector emitter voltage. So VCC is a supply voltage in output region. So V in the signal AC, which is to be amplified, given to the base emitter junction as shown in figure. Here base emitter junction is biased by VBE DC voltage. So according to Kirchhoff's law, VCC is equal to VCE plus IC into RN. Similarly, for the input loop, we have VBB is equal to VBE plus IB into RB, that is the input resistance. When some AC signal is applied, that is VI is a not zero, which is to be amplified. VI is a not zero, and we can write VBE plus VI is equal to VBE plus IB into RB plus a delta IB into bracket RB plus RI. The change in VBE can be related to the input resistance and the change in base current IB. Hence, we can write phi I, that is equal to delta IB into bracket RB plus RI, which is equal to delta IB into RI, because RB, that is the resistance of base, is very small. Changes in the base current cause the changes in the collector current. We will now define the AC current gain as a beta AC, and beta AC is equal to IC upon IB. The AC current gain beta AC is almost same as the DC current gain beta DC for the normal operating voltage. So we have delta VCC is equal to delta VCE plus RL into IC, which is equal to 0. Therefore, we have VCE is equal to minus RL into IC. The change in output voltage delta VCE is the output voltage VO. Hence, we can write VO is equal to delta VCE is equal to beta AC RL into delta IB. We now define the voltage gain AV of the amplifier as A suffix phi is equal to VO upon VI, which is equal to delta VCE divided by RI into delta IB. So voltage gains hence can be written as AV, that is equal to beta AC minus beta AC RL upon RI. So here negative sign indicates that the output is out of phase that of the input. So here that is the physical significance of negative sign. We can therefore write the power gain AP also as AP, that is equal to beta AC into A suffix phi. We have ignored the negative sign for the voltage gain to write its magnitude. We can a transistor can have a gain power because beta AC is greater than 1. So this is about the transistor used as an. So this is about the transistor. In this topic, we see that the transistor, how transistor used as an amplifier when it is connected in common emitter. Then output characteristic and formula for RO, that is output resistance. Similarly, input characteristic and formula for input resistance, that is a RI. And then working of NPN transistor, a relation between emitter current, base current, and collector current. Then the current gain alpha and beta, their formulas, and relation between alpha and beta also. Then we also see the 3 types of configuration of transistors connection. Basically, the types of transistors, that is PNP and NPN. So dear students, we stop here.